Today's assignment is on ratios on page 163, numbers 3 through 12. A couple things to keep in mind when you're doing this is when you're looking at the problems on 3 through 10, you want to be sure that you have the same terms on both sides. Number 3, 4, and 5 is all the same. Number 6 is the same, but number 7, let's look at that one. That one's different. You have 30 inches to 8 feet. So you can't compare inches to feet in what we're doing today. What you want to do is convert one to the other. So I could convert 30 inches into feet, but 30 inches wouldn't be an even number of feet. So it's easier to convert 8 feet into inches. Now, you already know that there are 12 inches in every foot. So let's do just a quick ratio problem here. If there are 8 feet, you're going to have to multiply that by 12 to get the number of inches there. So 12 times 8 gives you 96 inches. So when you rewrite this, instead of 8 feet, it's going to read 30 inches to 96 inches. Now 30 to 96 can be written in reduced terms. And also remember, you can write this in a few different ways. So you can make that 30 inches to 96 inches. I prefer fractional. That's the most mathematical you'll work with. 30 over 96, like this. So you can see a ratio in a number of ways. Now what you want is a common factor between 30 and 96. And actually 6 is probably the easiest one that pops out. 3 or 6 would come to mind first. So on top, what you're going to have is 5. On the bottom, 10 sixes make 60, so you need 6 more. So let's make that 5 over 16. So here's your final answer. Your inches will cancel out just like they were x's or y's. Anything is same on top and bottom. So your ratio reduces to 5 over 16. So watch out if you have two separate terms. Number 8 is yards to feet. There are 3 feet in each yard, so you need to do that conversion. Number 9 and 10 deals with minutes and hours, so make sure you make the proper conversion there. There are 60 minutes in every hour, of course. All right, next, let's look at 11. What you've got, it says find the best buy based on price per unit for each item. Give the unit price the nearest thousandth for that size. Now, thousandth is your third number past the decimal point. And it says granulated sugar, 4 pounds, is the same as, is $1.78. And 10 pounds is $4.39. So you've got a couple of different ways of seeing just how much are you paying. You can get the price per pound, or you can get the how much you get for the amount of money. Price per pound is probably the simplest. So unit price, if 4 pounds is $1.78, then to figure out how much it is a pound, you're going to take $1.78 and you're going to divide that by 4. Now put your decimal in line with where it is in your problem. 17 divided by 4. 4 will go in there evenly. So take 16 away. 17 minus 16 is 1. Bring your 8 down. 4 goes into 18 4 times. 4 times 4 is 16. Now you're going to get a remainder of 2 right here. You're not done. Put a 0 in, extend your bar, bring that 0 down. 20 divided by 4 is 5, and you know you're done. So you're at a 0.445. That's 44.5 cents unit price here. Now let's do the 10 pounds for $4.39. So take your 439, and when you divide that by 10, you actually don't need to do this whole process right here. You just move your decimal over one space. So that equals 43.9 cents, or 0.439. So this is your better buy. The 10 pounds for $4.39 is your best buy. Let's get this cleared off and let's look at number 12. Number 12 is comparing coffee. You've got 13 for $2.58. to compare that to 39, that's ounces, and that 39 would be $4.44. So just like we did in the last example, what you're going to do is take 258 divided by 13. Now here's probably what most of you are going to do. You're going to use your calculator. And you're going to do 258, and you're going to divide that by 13. And you're going to get 86 cents. And that's going to be 86 cents per ounce. For the other one, you're going to take your price, 444. You're going to divide that by 39 ounces. And I messed up. Try it again. 444 divided by 39. And you get, now I said thousands, so this is 0.1138. So if I have to stop at the 3, then that needs to round up to a 4 since my next digit was an 8. Now look at what's happening here. You've got 86 cents an ounce here, and you've got 11.4 cents an ounce here. So obviously this is a much better buy. Now one of the common mistakes that's going to happen is you're going to do this backwards. You're going to do 13 for 258. And you're going to do 13 divided by 258. Let's record that answer. That answer is 5.0. We're going to call it 504. If I do it backwards on the other one as well, and I do 30, clear that, 39 divided by 444, that one's going to give me 8.78. Now if you think about what that means, this is ounces for 444, and this is 13 ounces for 258. The 504 and 878 don't tell you nearly as much as what this will tell you up here. You don't have a way to combine. But what this is saying is you're getting more ounces for your money, where this is saying you're paying less money for your ounces. So that's where you get confused. You want to make sure you start the right way. Start with money if you want to end with money. And the mathematical way of showing that to avoid that confusion is if you're wanting the price per ounce, you're going to do 39 ounces last. Let's put my labels in there. I'm going to extend that out. You notice in your answer you've got $ over ounces. That is actually a fraction. So when you reduce that, you're dividing both by 39, and you're getting the cost per ounce. And we did 444 divided by 39, and that's where the 0.114 over 1 ounce comes into play. This works the same way. When we did it upside down, what you were solving for, you were actually solving for the amount that you were getting for your money, which is confusing. So stay with your $ on top, all right? That makes it much simpler. But it all boils down to 39 ounces for 11.4 cents an ounce is your best buy.